Hello, welcome to lesson 3.4. Today we're going to be talking about slope, which is also known as rate of change. Today's I can statement is, I can find slope and interpret its meaning. So by the end of class today, if somebody says, hey, what's the slope of that line, you'll be able to tell them, and you'll also be able to tell them what that means. So let's talk about what slope and rate of change actually is. Slope, which is abbreviated M, is also the same thing as rate of change. If you're talking about a roof, like if you're a construction worker, slope also means pitch. So if someone says, hey, the pitch of the roof is such and such, then they're talking about slope. And if you're talking about a hill, sometimes it's called grade. If you're driving through the mountains, you actually might see a sign that says grade of a hill. So basically all four of these words, slope, rate of change, pitch, and grade, it tells how steep a line is. The bigger the slope, the greater the number, and the direction of the line. So if it's a positive slope, that means it goes up from left to right, and if it's negative, it goes down from left to right. So let me draw a quick picture here, and you can draw this on your paper. A positive slope would go up like this. And if it was a negative slope, put a negative sign here, it would go down. Okay? So now, there's a lot of different ways to find slope. And if there's one super important thing on this set of guided notes, if anything is important, it's this. So I would highlight this on your notes. I would put a star next to it, and I would come back to it often. I know a lot of times we don't like to use our notes, but this little section that I just bubbled is going to be so important. So there's three ways that you can find slope, and it all depends on what type of problem it is, will dictate which one of these you use. If you're given 2 points, you'll use the formula. So if you're given two ordered pairs, you'll use the formula. But if you're just given a picture of a line, so for instance, if you're given something like this, then you would use rise over run. Rise over run, let's talk about what that means real quick, and let's maybe put some symbols right next to it. Rise means how much a line goes up or down. So that's what rise means. Run means how much a line goes left or right. And finally, if you're given an equation, you have to get y by itself, and then you can look down here and you can see what the m is. So we'll talk about all three of these points, but again, I want to stress, circle this, keep it handy. You might want to write it on an index card, but this is super helpful. So let's jump right into example number 1. Example 1, which corresponds with homework problem number 1, says find the slope of the line that goes through the given points. Now again, I'm going to say this a lot during this video, but you need to go back to those formulas. Now, we have 3 of them. We have a formula, we have rise over run, and then we have the equation. We use the formula with this point because we're given points. So let's go ahead and begin. On your guided notes, write down the formula. The formula is y2 minus y1 over x2 minus x1. Those little 2's and 1's are not exponents. They just tell you the direction to go. So I like to draw lines. So the first thing I'm going to do is I'm going to draw a line from this y to this y. And we're going to subtract them. That's what our formula says to do. So on the top, we're going to go -6 minus 6 over, and then we'll go our x's. We have to go the same direction. So we'll go -3 minus 5. That's our formula. You subtract the y's up top and you subtract the x's on the bottom. I've taught this for a long time, and the place where students always make a mistake is they always try to subtract the x's on the top. Just be careful, go slow, draw your lines. -6 minus 6 is -12. And -3 minus 5, excuse me, is -8. We always have to reduce. You need to notice on this problem that we have two negatives. Negatives always cancel out, so we'll go cancel those out. And 12 over 8 reduces to 3 over 2. And that's our final answer. And that's all you do on that problem. You simply have to use this formula. You learned this formula last year. It's just a matter of putting it in your brain and remembering to always subtract the y's on top. One quick note before we go on any further. I do want to say that you can go the opposite direction with these points if you'd like. So let me erase this. If you go the opposite direction, and what I mean by opposite direction is if you'd like to subtract the y's in this order, so if you wanted to go 6 minus -6 over 5 minus -3, that is perfectly acceptable. The only thing you have to be aware of is that these arrows right here have to go in the same direction. So on the y's, if you go this way, then on the x's, you have to go the same way. So that's that example. Let's do one more example like this one. Okay, here's here's example number 2 that goes with homework problem number 3. We're going to use our formula, which is y minus y over x minus x. I know that we usually have those little 2's and 1's, but sometimes I just write y minus y. As long as you remember to go in the same direction, then you'll be okay. So I'm going to look at these numbers, and I'm going to kind of use some common sense. I don't like negative numbers, so my y's are 3 and 6. So if I don't want a negative number, I'm going to go this way this time. So I'm going to go 6 minus 3. Over. Now, since I went 6 minus 3, I've got to go this way. That is very important. You got to go the same direction with your x's. So we've got 5 minus 5. Now let's do a little bit of arithmetic here. Here we go. 6 minus 3 is 3, and 5 minus 5 is 0. Now, let's talk about this real quick. 3 divided by 0 is not 0. A lot of times we'll put 0 as our answer, but that is not correct. If you type this in on your calculator, 3 divided by 0, you're going to get a word that pops up that says error, which means that 3 divided by 0 is undefined. And that's our answer. If it was reversed, if it had been 3 over 0, then the answer would equal 0. So just be careful. Type it in your calculator. 3 divided by 0 will come up error. So there you go. Now that we're to this point, you should be able to go to your homework, and you should be able to do the first 3 homework problems. So pause this video, go do problems 1 through 3, and then come back. Welcome back. I hope you did good on your first 3 problems. Let's go ahead and jump in and do the third example. The third example corresponds with homework problem number 4 on your assignment. And this time we're not given 2 ordered pairs like we were on the first 3 homework problems. We're given an actual picture of a line. Now again, you need to refer back to that very first section of your guided notes. If you're given points, use the formula. If you're given a line, use rise over run. So that's what we're going to do. Now, let's recall rise. What does rise mean? That means how much a line goes up or how much a line goes down. If it goes up, it's going to be a positive number. If it goes down, it's going to be a negative number. So let's start right there before we get into the next thing. Rise. There's 2 points on this line. I always start with the point on the left-hand side. It's kind of like, for me, like reading a book. I would not read a book from the right to the left. So I want to find the point that's on the right-hand side. So it would be this point. This is where I would start because it's on the, it's on the left-hand side. So our job is going to basically be to count from this point to this point. So we're going from here to here. So let's begin. If we count here, we're going to count how many we go up or down. Well, since this line is going down, notice this line is going down, we're going to count down. So we go down 1, 2, 3. Since we counted down, our rise is going to be -3 for this problem because we counted down. Now let's talk about the other word, run. Run means how much you go right or left. If you go right, you're going to the positive side of the number line, so you'd be counting positive. If you go left on a number line, you're going towards the negatives. So here we go. Let's count our run. 1, 2, 3, and 4. So our run is +4 because we counted to the left. Now, make sure you're counting how many steps you take. Just be careful not to miscount. So we're going to write this as a fraction. So our final answer would be -3 over 4. This problem, this fraction, does not reduce. So that would be our final answer. So, to recap, if you're given a picture of a line, simply start with the point on the left-hand side, count up or down. If you go up, it's a positive number. If you go down, it's a negative number. And then count left or right. And that's how you do that problem right there. Let's do one more quick graph a problem where there's a line on a graph before we go to our homework. This is important that you see this one because this is kind of a unique one. So let's go to the next slide. Okay, here's our next example. This is example 4, and this corresponds with homework problem number 5. So this is kind of a unique line. It's a vertical line. Vertical lines don't have positive slope and they don't have negative slope because honestly, who can tell if this line's going up or down? It's kind of going both. So it's a unique situation. Vertical lines such as the one in this particular example, have undefined slope. You need to make a note of that. So the answer to this would be undefined. So let's real quick, before we go on, let's talk about the opposite of a vertical line. Let's say we have a parallel line. Why don't everybody draw an example of a parallel line on their paper? I'm going to draw mine right here. This is kind of the opposite. So vertical lines have undefined slope. Horizontal lines have zero slope. So I think this is probably pretty important that you put in your notes. So draw an example of that. Let's kind of maybe draw an arrow right there. And then we'll draw an arrow right there. And we're set. So up to this point, we've talked about 4 different types of slopes. A line can have positive slope. That means it's going up from left to right. A line can have negative slope. That means it's going down from left to right. And then we've talked about the 2 unique cases on this slide. If it goes straight up and down, if it's a vertical line, it has undefined slope. And if it's a horizontal line, it has 0 slope. So at this point, you're good to go. You should be able to go to your homework and do practice problems number 4 through number 8. Last piece of advice, take your time, count slowly. Okay, at this point, you should be all the way through problem number 8 on your homework and moving right along. At this point, we've also done examples where you use the formula. And remember, if you're given 2 points, simply use that formula, plug it in, and solve very carefully. And we've also done problems that require you to just simply count. Rise over run. Count up and then count over. Or count down and count over. So that's where we're at to this point. So let's go ahead and bring in homework or example number 5, which corresponds with homework problem number 9. Okay, here we go. Okay, we're given 2 lines. We're given the line L1 and L1. I'll just underline it here. L1 is the blue line. And we're given L2, and L2 is the red line. It simply wants to know which one of these has the greatest slope. So I kind of think of this problem as kind of a common sense problem. Look at these 2 lines. One has positive slope and one has negative slope. So let's start right there. Which one of these lines has positive slope? I want you to go ahead and maybe out to the side of it, right here, write positive or write negative. Which one of these has a positive slope? Which one has a negative slope? If you said the blue line has positive slope, then you're correct, which means that the red line would have negative slope. So it wants to know which one's bigger. Well, positive numbers are always bigger than negative numbers. There's no exception to that rule. So our biggest line, our line with the greatest slope, I should say, would be the blue line, which is L1. Just because it's positive and the other one's negative. I do want to address one real quick thing before we pause this and go on, though. A lot of students in the past have always asked, well, how do you know? It depends on which way you look at the line. This line could be going up. And what they mean is, if they look at it from here and go this way, well, this line's going up. And they say, well, Mr. Schulter, this line could be going down. What if I start right here and I go down? They say it's all about how you look at the line, so how am I supposed to know? Here's how you're supposed to know. You look at these lines like you look at a book. You start on the left side of the page, on the left, and you move to the right. So if you're going to look at this line, you need to start right here because that's the point on the left. You're going this way, that's going up. If you're looking at the red line, you need to start at the point on the left and you need to move to the right, which means that this is going down. So essentially, you always have to start at the left and then move to the right. So that covers that problem. Let's do a couple more problems and then we'll go on to our assignment. Okay, let's go ahead and knock out 2 problems, number 6 and number 7, at once. So, find the slope of the line x equals 6. What I'm going to do, and what I think you guys should do, is just draw a very quick sketch of a coordinate plane. I'm going to draw one here, and we go ahead and draw one on here as well. So, find the slope of a line, the line x equals 6. Now, we've talked about this several times in notes and several times in class. My question for you is, what is not in that problem that is in typically most problems? If you said there's no y, that's correct. If there is no y in a problem, that means it will never touch the y-axis. No y, no y-axis. So what type of line does not touch the y-axis? Well, a vertical line. So before we answer question 6, let's drop down to question number 7 and do kind of the same thing. So let's look at this equation, y equals 3. It's always important to notice what's in an equation and what's not in an equation. So if we look at this equation right here and we ask ourselves what is not in that equation, then we would say that there is no x in that equation. And if there's no x, that means it's not going to touch the x-axis, which means we'll have to have a horizontal line. Okay, so we have our lines drawn. Some of you guys can maybe do this mentally, but for most of you, including myself, I'm a visual person. I need to draw a picture of it. So now that we have these two lines, we can go back in our notes and we can say that a vertical line has undefined slope and a horizontal line has 0 slope. So those are our answers. X equals 6 has undefined slope, and y equals 3 has 0 slope. Let's go on to our next example real quick. The next example is going to be really easy. Okay, we're on problem number 8. And we have the third type of kind of slope setup here. Let's kind of do a quick recap. If we're given 2 points, we use the formula. If we're given a picture of a line, then we can count rise over run. If we're given an equation, it actually might be the easiest of the three. So let's talk about this real quick. First of all, in order to use this method, it has to be in this form. Y equals mx plus b. Now, right now you might think, well, that looks awfully funny, but the main thing you need to worry about is you must have y by itself. You must have y by itself. If y is isolated, then it's really, really easy. The number in front of x, the coefficient of x, which in our formula is called m, this is always, always, always our slope. So let's recap. If y is by itself, then all you have to do is look at the number that's in front of x, the number that's attached to x, that's called our coefficient, and that is always your slope. It's as easy as that. There's nothing else you have to do. So in this problem right here, it might be our easiest problem of the day. We just look at it. Y is by itself. That's important. The number with x is 0.4, and that means that is our answer. So our answer, and we can abbreviate, m equals 0.4. I don't guess I've addressed it yet in these notes, but the abbreviation for slope is m. So when you see m, that actually means slope. So there you go. Let's do one more problem. I know we've done about 5 in a row, but this will be our last problem, and then you'll be able to pause the video and you'll be able to knock out about 7 problems. But this problem right here is kind of confusing, so hopefully you'll watch this. Let's go ahead and go to the next slide and do this example. Okay, our next example is kind of like the previous example. The only difference is y is not by itself. Y is not by itself, so we've got to get it that way. But we're not going to use the formula because we're not given points. We are not going to use rise over run because we don't have an actual picture of a line. So we're simply going to get y by itself. So let's use our algebraic skills that you've learned last chapter to get y by itself. So let's write the problem down. We've got 4x minus 5y equals 20. I always like to draw that line down the center. And let's start moving things to the other side. The first thing we need to move is we need to get the x on the other side. So we are going to go minus 4x and minus 4x. Now, a common mistake that students make here is sometimes they will see this subtraction sign and think, oh, the inverse of subtraction is addition. So they'll add here. But 4 plus 4 would be 8. This minus sign goes with the 5. This is a positive 4, so we subtract. So here we go. These cancel out. We are left with negative 5y equals These are not like terms. These are not like terms, so do not subtract them. 20 minus 4x. Okay, next step. We've got to get rid of this negative 5. So we go divide by negative 5. And then we have to divide everything on the other side by negative 5 as well. Some people do this, which is perfectly fine. That's a perfectly fine method to do it. Personally, I prefer to do it this way. Either way is fine. And now, let's reduce. These 5's cancel. We're left with y equals 20 divided by negative 5 is negative 4. Now, here's the part that can be tricky. We have two negatives here. Two negatives cancel out and make a positive. 4 over 5 does not reduce, so we still have our fraction, x. There we go. Now that we have y by itself, it's very simple. That process that we just did, it can maybe be a little bit complicated, but just take your time. But once y is by itself, once it's in this form, we simply look at the number with x, the coefficient of x, which is right here, and that is our answer. Our slope is 4 over 5. Slope is always the number with x as long as y is by itself. So, we're done with example problems 5 through 9. You need to go ahead and pause this video. You need to go to your homework, and you should be able to do practice problems 10 through 17. Okay, at this point, you should be all the way done with problems 1 through 17 on your homework assignment. You don't have many problems left. So let's jump in here and let's talk about parallel and perpendicular lines and kind of how their slopes are related to one another. Okay, I've brought these two things side by side. Parallel lines, I think we all know what parallel lines look like. I'm going to do my best to draw straight lines here. Not too bad. Parallel lines never intersect. Notice, slope is the angle that a line goes up. Slope is an angle that a line goes up. These lines go up at the same angle, and since they never touch, that means they have the same slope. Parallel lines have the exact same slope. So let me throw you an example down here. If I gave you an equation and it was like this, let's go, we'll do red one is y equals 3x plus 2. And let's say the green line, let's say the equation for the green line was y equals negative 5 plus 3x. Learning what we learned a few minutes ago about finding out what slope is, you can simply look at these equations and say, hey, their coefficient of x are the same. That means their slopes are the same, so these lines are parallel. So if I give you just this, you don't need a picture of a line. You don't need anything. You can just look at these two equations and say, hey, their slopes are the same. They must be parallel. And there we go. There's that one. Now, perpendicular lines, we'll go back to the red and green. Perpendicular lines intersect at 90-degree angles. So every one of these little angles here, even though it's not perfect, are 90 degrees. So perpendicular lines have opposite and reciprocal slopes. So for instance, let's talk about opposite and reciprocal. I'll give you a couple examples. So for instance, let's say we have a number 3. The opposite of 3 is negative 3, so we're going to have to make it negative, and the reciprocal of 3 is 1/3. Let's do another one. What if I gave you negative 1/2? Well, the opposite is positive 1/2, and then we have to flip it to make its reciprocal, so it's going to be positive 2. And one last one. Let's say I give you 3/4. The opposite is negative 3/4, but we have to flip it to make its reciprocal, so it would be negative 4/3. So that's kind of what we're talking about there. Now, I would venture to say that almost everybody in this class would know a set of parallel lines, or perpendicular lines if you saw them on a graph. But what happens if you're just given an equation? So for instance, let's say you're given this equation, y equals 1/2 x plus 5. And then I come and I give you another equation and say, hey, are these perpendicular? Y equals negative 2x plus 3. These numbers back here don't matter at all. We're looking at our slopes, and our slopes are these numbers right here. So the question you have to ask yourself, are they negative reciprocals? Are they opposites? They are opposites. One's positive, one's negative, and they are reciprocals. So you would be able to say, without seeing a picture of a line, without seeing a graph, you can just look at these equations and say that those lines are perpendicular because their slopes, these two numbers right here, are opposite reciprocals. So let's use this information we just gained to do one quick problem. Okay, our problem is this. Determine whether these lines are parallel, perpendicular, or neither. So it all comes down to one word. It all comes down to their slope. It's all about the slope. Their slope tells us everything. So we need to find the slope. So I'm going to start by rewriting the first equation. We've got y equals 5x minus 9. Everybody on your paper, circle what the slope is. If you said 5, you're right. So the slope of this line is 5. Remember, the abbreviation for slope is m. Okay, that was easy. That was super easy. Remember, if y is by itself, then it's so easy. Let's look at the next equation. X minus 7y equals negative 1. Now, remember, this is so important and it's so easily forgotten. You cannot determine slope unless y is by itself. So we've got to get y by itself. The first thing I'm going to do, and I like to do this, is I like to put a coefficient with the x. So we're going to make it 1. We need to get that to the other side, so we're going to subtract 1x. And we're left with negative 7y equals negative 1 minus 1x. We need to divide by negative 7. Remember, divide everything by negative 7. And we are left with these cancel. We're left with just y equals positive 1/7 because the two negatives cancel out. Be careful here. Got two negatives. Those are going to cancel out as well. We're going to be left with plus 1/7x. So here's our slope on this problem. M equals 1/7. They're certainly not parallel, so I'm going to put a big X through that. Parallel lines have the same slope, and they're not perpendicular either because they're not negative reciprocal. Just to practice, if the negative reciprocal slope of positive 5 would be negative 1/5, and that's certainly not negative 1/5, so we can say they are neither. So, since they're neither, if they're on a graph, I'll just erase this slope real quick. If they're on a graph, they wouldn't be parallel, they wouldn't be perpendicular, so maybe they'd look something like this. Those intersect, but they're not perpendicular because these angles right here are not 90-degree angles. So, a little bit tricky. You just had to get y by itself, and then you just had to look at their slopes. If they were the same, parallel. If they were opposite reciprocals or negative reciprocals, they would be perpendicular, but these weren't in this problem. So, you're done with this problem. You should be able to go to problems number 18 and 19 and do those problems at this point. Okay, at this point of the note, you should be finished with the first 19 problems. And now you're on to the word problems. Let's do example number 11. This is our last example, and we're going to hit a word problem. Okay, so word problems are real life problems. So you've been doing all of these problems 1 through 19, and in the back of your head, I'm sure part of you is thinking, when are we ever going to use this in real life? Well, you'll see some real life problems, some application type problems in the next 5 problems on your homework, and we're going to talk about one of them right here. So, in Owensboro, you always see roads being fixed and paved and stuff like that, and it's important whenever they're doing road construction to know this word right here, the grade of the road. And grade simply means slope. So, real world problem. Okay, the grade of the road is its slope written as a percent. Find the grade of the road shown. Round your answer to 1 decimal. So, hopefully, at this point, we realize there are 3 different ways to find slope. We can use our formula, but we use that if we're given a set of ordered pairs. There are no ordered pairs in this problem, so the formula is out. If we have an equation, we can just see what the number with x is. Well, we don't have an equation. So what we have here is a perfect real-life example of when rise over run will be put to use. So, rise means up or down. So which one of these 2 numbers is our rise? If you said 2, then you're correct. 2 is our rise. And run. Run means over. So here we go. Over 21. Our rise over run is 2 over 21. Now, you need to pause right here. Not pause the video, but you need to think. Most students that do this problem would type in 2 over 21 and they'd get it wrong. And the reason that they get it wrong is because they don't read the whole problem. So when you're doing the ACT or the plan test, it's so important that you read the problem. Look what this says. The grade of the road is its slope, written as a percent. So we need to convert this to a percent. So in order to convert it to a percent, we need to divide. 2 divided by 21 is 0.0953. And then from there, you can do one of 2 things. You can multiply by 100, or you can simply move the decimal place 2 spots to the right. So we get for our answer 9.52. Now, looking at your homework, it looks like they say round to 1 decimal place. So I just glanced at your homework, so we can simply mark this off. Our final answer would be 9.5, and let's throw a percent sign over here. So there we go. Now, you're going to have a couple more word problems in your homework. Take your time. Make sure you pick out all the keywords like percent, and if you have any questions with those, raise your hand. I want to do one last slide before I let you go. Bring in this one more time. I want to wrap this up by bringing in this part of the notes one more time because I think it's so very important. There are 3 different ways to find slope. If you're given a point, you should use your formula. So for instance, I'll do kind of an example. This is going to be really quick. If the problem says something like this, 3, 2, -1, 4, and then it says find the slope, this is what you're going to use. Next problem, if you're given a line, so for instance, if you're given a coordinate plane that looks something like this, and they put a dot right here, and they put a dot right here, and there's a line through it, you're going to use rise over run. You're going to count up 1, 2, 3 over 1, 2, 3, 4. And finally, if you're given an equation, you have to get y by itself. So for instance, if you have a problem like this, 3x plus y equals 5, you would simply go minus 3x, y equals 5 minus 3x, and you would be able to say, hey, -3 is my slope. So I think this is such an important slide. You're going to use all of 3 of these in today's lesson. This wraps up these video notes. Take your time. Please watch the video. If you have any questions, raise your hand. Have a good day.